And it's recording. All right. So 2A was revision of angles. So you had to know reflex, acute, obtuse, supplementary, complementary. 2B to me was the hardest. That's the parallel. And that's where I talked about co-interior, corresponding versus alternate vertically opposite. This is the hardest. If you're still struggling in this one, that's okay. Don't spend too long on it. Maybe move on 2C to build some confidence and then come back. All right, because 2B is one of the hardest ones to understand and memorize. 2C today is a lot easier. It is just to do with triangles only. Most students can label triangles and solve triangles as well. Not so much 2B. So 2C today, there are 3 types of triangles. We call this middle one, actually not this middle one, this one over here that everyone seems to know. What is the name of this last triangle over here? Can I please have, yes, Macy? Equilateral. So we've got equilateral triangle. What's the features of an equilateral triangle? Let's go with Harrison. What do these dashes mean? Very good. These dashes, which at a year 8 level, I do expect when you're drawing equilateral triangles, you must put in a dash. Doesn't have to be 2. It could be 1 dash, but they all have to have the same dashes. So if they have all the same dashes, it implies all the lengths of each one is the same. 3 sides are the same. Therefore, here all have same sides. But not only that, what's another feature of an equilateral triangle? Let's go with Mark. We've got all the sides are the same and... Very good. All the corner angles, okay, we call that internal angles. So each vertice or corner, each of them have the same angle. Now, the nice thing about equilateral is that they all have the exact same number. Now, we know what that number is. Anyone know? Hands up. What's the number? Tejas? 60 degrees. It has to be 60 degrees because there's a property that you're meant to know. So all have 60-degree angle. How do we know that it is 60? Can someone tell me? How do we know that it's definitely 60? James?
Because they all add up to 180.
Beautiful. So here, all interior angles in a triangle must add up to 180 degrees. That's a fact of a triangle that we needed to know from year 7. And if you got 3 of them, and since all of the angles are the same, 180 divided by 3, that's how we know each one has to be 60 degrees for that to be true. So 60 plus 60 plus 60, that's how you get 180. And we know that all the angles in a triangle must add up to 180. So therefore, 60 degrees for equilateral. Good. Let's look at the middle one. What if you have 2 sides that are equivalent? What is that one called? Can I please have... Let's go with Joachim. Do you know this one? The middle one. If 2 sides are the same. What's the name of this triangle? It's okay. This is what we're testing today. Just to learn. Starts with I. Someone just whispered it. Who said that? Tiana? Isosceles. Very good. So let's write this down if you didn't know. Isosceles triangle. Okay. So isos and then celes. Isosceles triangle. And we know that's when you have 2 sides that are the same. And if those 2 sides are the same, you can think of it as like a mirror image. If I split this in half directly down, whatever's on this side is equivalent to that side. Therefore, whatever this angle is, that must be the same. And notice the way they use 2 arcs and 2 arcs to signify that they're both the same angle. So these 2 angles must be the same. So here we say have 2 sides the same length, and we say have 2 angles that are the same. Yes? You don't have to have 2. So you can do 1, but if you do 1 for a corner, and because it's equilateral, you have to do 1 for all of them. Usually we use different number of arcs to show it's different. So for example, this one, instead of doing the symbols, right, what you can do is you can draw the shape and to say, this angle I can do 1 arc, and then say this is a different angle, I can do 2 arcs to say it's different. And if the third angle is not the same as the first 2, then I do 1, 2, 3. So that's one way of doing it. So the number of arcs just to say it's different to another one. So why is this one only 2? It's because it's showing there's nothing here. So I could have done one angle there, and that's to say these two are the same. That one's different to these two because these have 2 arcs. The other one only has 1 arc. Alternatively, you could do what this diagram did, where you can actually just put a symbol for it. So dot, open circle, and a cross. That's another way to show that they're all different as well. Or you could have done dot and dot to show that those two are the same. All right. And so what are you taking out of this year 8 sort of course on labeling? It's not just identifying what shape it is. You also have to know how to use the symbols. So when I look through your homework, that's what I'm looking for. Most students who are really strong at mathematics usually are very detailed. So their triangles have the details in it. That's how I know. And then for most students who really struggle with general mathematics, I will see their triangles will not have notations. It's one of the easiest ways to tell if the student knows their theory or not. So make sure to draw in the notations for me to know that you know what they mean. Last one. So we've got isosceles, equilateral. What is the last one? Starting with S, hands up. Yes, stages? Scaling. Scaling in this case, as you can see, all the markings. One has 1 dash, the other one has 2, the other one has 3, implying all have different side lengths. And then notice that all the angles have a different symbol. So it means all have different angles. That's part of your learning map. So if I look through your homework and I can see that you're now able to draw the triangles with the appropriate notation, you can tell the difference between each one. That's part of the learning map. I'll tick off that skill. Okay, so if I'm confident that you know the difference, then I'll tick it off. If I'm not confident, I won't tick it off. Yeah? All right, so we already know all the angles in a triangle must add up to 180. There is an angle theorem called the exterior angle theorem that some students know, some know it intuitively, and then some actually know the rule. This angle theorem says exterior means on the outside of the triangle. Angle Z is the exterior angle. It is equivalent to the 2 opposite interior angles added together. So you see, these 2 are opposite to the exterior. If you add these 2 together, it should equal to the one on the outside. That's what the exterior angle theorem is. So what do you fill in? It says the exterior angle of a triangle is equal to the sum of the 2 opposite interior angles. Here's the formula to help you remember. If you draw the diagram in your notes, Z is equal to X plus Y. I can show you the proof to this very logically as well. So here's an example. Let's say I told you this was, that's an obtuse angle. Let's do 150. This is an acute. Let's say this is, let's go with 10. Okay. Let's say you didn't know the angle theorem, the exterior angle theorem. You can still calculate this because in a triangle, so here's the triangle. What must all the corner angles add up to again? Fraser? 180. Now we already got 150 plus 10, which gives you 160. What should this angle be? 20. So logically, this is meant to be 20, but here's the funny part. You see, you told me just now, 150 plus 10 plus that leftover angle is meant to equal to 180. True? But here's another fact. This is a straight line. So if I just take off the yellow coloring so you don't get confused, that's a straight line. And we learned in exercise 2a, a straight line has a total angle of 180. So that means from here to here, that's a half circle. All of this should add up to 180. But if you know this is 20, what should this one be? Yes, it should be 160. Now here's the interesting thing. If I didn't know that was 20, but I said this was B, and this is A plus B has to add up to what again? 180. So A plus B is meant to equal to 180. Can you see where the formula is coming from now? That, if you add these two, so the missing number is B, that 20, I'm going to call that a B now. Can you see, if that's B, the little angle B, and that's also B, A must be this. A is the exterior angle, A, and you told me 150 plus 10, that must be A plus B to equal to 180. They're both equal to 180. See that? So both equals to 180. They both have a B. The only thing one side is missing is this has an A. That means these two have to be an A. That's why we say 150 plus 10, the opposite angles must add up to A, which is the exterior angle. If you don't understand that proof, that's okay. I'm just saying that most of you will be able to figure it out without the rule, but there is a problem-solving question that without the rule, you'll find it really hard to do. So if you know the exterior angle theorem, you can solve those problem-solving ones. Otherwise, you get through with fluency. Okay? All right, here we go. Let's do a practice round. So 2 skills for today. You need to be able to label, identify different shapes. Last one is solve for angles in a triangle. 2 skills. Here we go. Here's the first one. Here's a triangle. First theory that we know, because it's a triangle, all the angles must add up to 180. So write out your thinking. Draw the diagram. Write out you got 23 plus 110 plus an angle that you don't know, which is called A, the corner angle. And it's meant to equal to 180. Now remember, you can use a calculator for this. But if you don't need it, here we go, let's add them together. What's 23 plus 110? Let's go, Quinn. 133, that's correct. So 133 plus something has to equal 180. So you can count with your fingers. What is that, Jay?
67 degrees.
Is it 67?
Is it?
Wow.
Oh no! I was right. Oh, that was 47 degrees. Queen, that's 47.
No, you can't blame Quinn. You got to blame yourself. If I said that 1 plus 1 is 10, I would hope that you would say, no, sir, that is wrong, rather than go, yes, sir, 1 plus 1 is 10. If you need to be critical about it. So whatever Quinn says to you, you got to think about it. So yes, the answer is 47, because you only need 7 more to make 140. And then once you're 140 to get to 180, it's another 40. So 40 plus 7 is 47. Very good. Next one. B. All right. So question B, in order to solve this problem, you need to identify the shape. So again, same thing. Even though I say all angles add up to 180, the problem is they've only given us 48 and A. I don't know what this angle is. That's why it's not possible to just rely on the fact that they all add up to 180. So you need to identify what shape do we have, James? Isosceles, very good. And what does that tell us?
It tells us that the left side and the right side are both the same.
So what's the angle?
A.
Very good. So for those who didn't realize, you see, you had to identify it's an isosceles. How do we know? There are 2 dashes here to say 2 sides are the same. And that means you got to find where they're symmetrical. And for me, cutting it in half is where it's symmetrical. Whatever's on the left must equal to what's on the right. That means whatever's on the left here, A, must also equal A on the right as well. So now you can put it all together. You can say A plus 48 has to equal to 180. But A and A are the same numbers. So you're essentially doubling that number. So 48 plus double a number equals 180 sounds really confusing. But if I just did this for you, if I just said 48 plus something equals 180. 48 plus what gives you 180? Harrison.
You just do 180 minus 48
Good. What's that?
is 32.
32. 132. Good. And
132 divided by 20.
beautiful. And why did Harrison decide to divide by 2? Yes, Mason. Because there's 2 A's. Remember, these 2 are the same numbers. You're doubling it. So when you say A plus A, it's the same thing as saying double of A will give you 132. So if you want to work backwards, we'll figure it out. We'll half it. 132 divided by 2 gives me... Is it? Yes, you're right. 66. I was wrong. Good thing I checked. 66 degrees. So A must be 66. Well done. Draw the diagram. Write out your question method. I want to see diagram, problem, method, answer. So that when you look back in 6 months' time, you know what you did. I don't just want to see A equals 66. Okay? So that's one way to help you. A plus A is the same thing as doubling A. 48 plus what gives you 180? It's 132. But since you're doubling A, divide by 2 to get A equals 66. Flip over. All right, let's try C. Let's pick another person. What does this box mean? Can I please have Osman? What does this little symbol mean? 90 degrees. That means right angle. Okay, so I got A, I've got 90, and I've also got this triangle. Now there's two ways to solve this problem. One's a lot quicker, and one may just take a few more steps. What's the most efficient way to calculate this problem? Rylan?
161 minus 90.
Beautiful, and how did you know that?
Because 161 is equal to A and 90.
Beautiful. I love it. This is the exterior angle theorem, so if you recognized it, this angle on the outside has to be equivalent to these two added together. So A, you write out your problem, you say A plus 90 should equal to 161 because you know it's exterior angle theorem. From here, that's what Rylan was saying. 161 take away 90 should then tell me A. So here we go. What's 161 take away 90? 71. Very good. Okay. There we go. Wait, is it 71? Yes, it is. Cool. It is 71 degrees. Good. And if you didn't know the angle theorem, again, you could have calculated this little corner here. So 161, that would have been 19. 19, and then you can add to 90 and then work out A. So that would have been the longer way to do it, but it would have worked. All right, last one for the problem today. And then the rest of the session is your time. Last problem. So what type of triangle do we have overall right now? So the one I'm highlighting in yellow. Yes, Fraser? Yes, and how did you know it was an isosceles?
Because I knew that there was two sides.
Good. We got the two sides that are the same, and it's also split down the middle. Very good. So if it's split down the middle, what can we say? What information can we take away from it, Fraser?
Both sides must be equal.
Very good. So this side over here, that's symmetrical. This side must also be 72. Now, even though I know that this corner is 72 and this corner is 72, I still don't know what this entire corner is. Okay, because I need to find this entire corner then to find out A. A is in between it. So it's split right in half. So how do I work out this entire angle? What do I do? Hands up if you know. What do you have to do? So we know this is 72. We know this is 72. I don't know what this corner is. How would I work that out? Yes, Pierre.
72 plus 72. And then 180 minus 72.
Very good. So remember, if I color it in, so adding this angle plus whatever this angle is, you can call it whatever you want. Let's call it B. Okay, so 72 plus B should equal to 180. Now 72 plus 72 is 144. So what should B be? What should this angle, entire thing, add up to? If 72 plus 72 is 144. How much more do you need to make 180, Ava? 36, good. So we need 36 here. So that means both of these angles here added together should be 36, but you only need half of it, which is then half of 36. Now what's half of 36? 18. That's why we know A must be 18. And so how you do it, divide this by 2. That's how you know A must then be 18. Or if you wanted to draw the diagram, you could have done it this way as well. You could have said this is A, so A plus A is 2A. So you could have said, instead of B, you could have said 2A, 2A, and then divide 36 by 2. That would work as well. So doesn't matter which notation you do, but I do want to see diagram, problem, how are you approaching it, method, answer. Okay, I don't want just to see answers. I want to see how you're working through it to get there. Pretty sure that's it for today. Thank you, team. I'm going to stop the video.